11.6 Cis-trans isomers. The atoms or groups of atoms attached to the carbon atoms of the double bond may form two different structures, and these are called cis or trans. And so you can visualize this. Pretend your fingers are a double bond here as you put your two fingers together, and pretend your thumbs are substituents. Now then, if your thumbs are on the same side, they are cis. If you rotate your hand and the thumbs are on opposite sides or across, that's trans, i.e. like a transatlantic voyage means you go across the Atlantic. Trans is it is across the double bond. What's amazing is you may go, oh, so what's the big deal if it's on the same side of the double bond or if it's across the double bond? Well, it's amazing all the different things you may have even heard of, like trans fats or things like that. Well, later on, as we learn more about it, we will see that. But right now, we need to identify cis and trans. So in an alkene, the double bond is rigid and does not rotate. If you remember right, we mentioned that this was trigonal planar. It was like a triangle all in one plane, and that we had this where it is like 120 degrees, it does not rotate. Well, because of that, if we put chlorine or some other substituent on one end and on the other, it could either be attached on the up carbon, in the up position or the down position. So if both of them are attached to the up positions of the two carbons, they're on the same side. Let's cut through the double bond here in our mind, draw a dotted line. You'll notice that this chlorine is on the same side. Whereas for the trans, if we have this imaginary dotted line between the double bond, they are on opposite side, trans. Now, this is a big deal because these molecules only fit in certain receptor sites that accept it. So if the molecule can accept cis, then it will only accept cis. If it only accepts trans, it's only going to accept trans. So depending on the molecule, the molecule might be absorbed in your body or not. Now then, so we mentioned earlier about making, the cis-trans isomers. They are different isomers. They have different physical and different chemical properties. So they are different molecules. Even though, so let me go back to this one, even though if we were to look at 1,2-dichloroethene here, you may think, oh, well, that's one molecule. When you then take it out of the just plain, squished spider view that I call, and you actually visualize how it can be set up, it can be set up either way. So these two different ways have different chemical and different physical properties. So for example, in this cis-2-butene, as opposed to the trans, one is more stable than the other. Can you try to think maybe which one might be more stable? Well, I hope you guessed that the trans, has some stability. Well, let's look and see and talk just for a second about cis and trans and how it relates to the environment. Pheromones. It has a picture here of a moth, and it says many insects emit minute quantities of chemicals called pheromones to send messages to others of the same species. Now, the pheromones may warn an insect of danger, they may mark a trail, and they may attract the opposite sex. Now, bees, out here in the desert where we're at, bees emit fight pheromones, and that's when they attack you. Depending on what kind of perfume you're wearing, it may attract the bees. It is amazing. And then if you have one bee that attacks you, it may emit a fight pheromone, and then you have everybody just coming, all the other bees coming to attack you. So pheromones is how the insects, one of the big way that they can communicate with each other. And the reason why they bring it up here, they don't mention a lot, but let's look at this pheromone bombicol. Now bombicol was the first sex pheromone that was actually synthesized and identified. It was identified in the 1950s. And you go, well, so who cares about a sex pheromone from a moth? Well, I'll tell you why. How do you make silk? Oh, well, from the silkworm moth. And so if you can make more silkworms, then you can make more silk. If you can figure out how to make more silkworms, then you might make a little bit of money. And so they figured out what the attractant was that attracted males to the females, so that the females would then lay more eggs and make more silkworms. And it was interesting. If you look up this information, it's very interesting in the fact that the guy noticed that, hey, wherever that female moth was, the male knew where she had been. He could somehow follow the trail. And so Adolf, the guy that was doing this research, figured it out and ended up identifying this bombicol as the first sex pheromone that was identified. And whether it's cis or trans is a really important item, because the males can identify one and can't identify the other. So here we go. Here's an example. They're using gumdrops. The green's on the same side, so that's going to be cis, and here the green's on opposite sides of the double bond, so that would be trans. Another item, since we do have a lot of agriculture here in Arizona still, by identifying these sex pheromones, let's say that you have a moth you don't like. For example, like the gypsy moth. The gypsy moth really can eat up forests and shade trees and fruit orchards. Not that we have a lot of forests here, but, well, so let's say that we want to get rid of those. They actually, instead of just spraying insecticides and pesticides, they can set up traps to lure the males by creating the pheromone of the female and setting in a trap, and all the males go, oh, there's a female, oh, let's go there, and then it gets sucked right into the trap, and then this way they can kill the males. If they kill all the males, and there's not males around to then make babies of moths, and so they can help eliminate pests through this way rather than through spraying chemicals. Just kind of an interesting link to the environment. This something so simple as cis and trans pheromones. So let's see, and I want you to be able to figure out if it's cis or trans as we look at a molecule. Well, here's our bromine. They are on the same side of our double bond. So cis 1,2 dibromoethene. Notice here the bromine is on the opposite sides of our double bond, so trans 1,2 dibromoethene. So identify this as cis or trans. I don't need you to name the whole molecule. Let's just identify, is it cis or trans? Okay. Press pause and come back. So we look here, these are on the same side, so it's going to be cis. Okay. These items that match here, they're on opposite sides, so it's going to be trans. In here, this is on opposite sides of the double bond, so trans.